Earthquakes is where we're going to spend our next number of lectures in our online open geology textbook. Earthquakes are covered in chapter 9. And this is actually going to be a series of 4 or 5 different videos as we explore faulting and then the energy that breaking those faults releases in the form of earthquakes. The story can be broken down in its simplest form to when the force provided by plate tectonics is greater than the strength of rocks, deformation will occur. And this deformation is going to occur in 2 main styles. One is brittle and the other is ductile. And we should go ahead and put that down. All right, so the types of deformation could be the heading here. Styles of deformation. We have ductile deformation, and this is the bending or smearing of rocks. This is strain without breaking. And number 2 is a brittle response. And brittle is ultimately where we're headed today. But as we go into this topic of earthquakes, let's just go through deformation briefly. Ductile is going to be recrystallization. It's going to be at this level, we're going to think about it as folding, where if we were to put a compressive stress on a straight layer of rocks, it could turn it into an accordion S. Or maybe we had a force on a rock and it just bends it like so. At the crystal level, we could take a square of rock and put shear stress on it, and it wouldn't shatter. Instead, it would change its shape to something more like this parallelogram. This is the field of metamorphism and structural geology. Now, with brittle response to that deformation, it's going to be faults and fractures. Faults and fractures. Now, fracture is, another word for fracture would be joint. The difference between a fault and a fracture is there's movement on a fault, and on a fracture there is no movement. It's just a broken rock. Earth's brittle response to stress, you could think about it with respect to a diagram. Graphing is such an important thing as you become better and better scientists. But if we were to look at the interior of the Earth in terms of its temperature and pressure, I think I've introduced this before, the interior of the Earth heats up as we go to deeper pressures, and this is called the geotherm. Well, if we plot ductile and brittle responses on this diagram, I bet you wouldn't be surprised to learn that brittle rocks are colder and at lower temperatures and pressures, and ductile rocks exist in the realm of depth and high temperature. Let's get some pictures real quick before we move on. Here is a cool picture, don't remember where I grabbed this one, of a rock that has been completely compressed and smeared and folded very tightly. Very impressive metamorphic folded rock. And now here's another picture. This one's really cool as well. And the faults might not stand out quite as clear to your eye, but look at this. Oop, here we go. Look at this. In red, that's a fault. In red, that's another fault. And we can see that it's a fault because this layer matches, right? That's a continuous layer, and so we had to have broken and down dropped this block relative to the other. All right, so let's continue on here with our notes. I would like to go through states of stress. Because our planet has, well, why did I say planet? Anyways, there are 3 different types of stress, just like there are 3 different main types of plate tectonic boundaries: convergence, divergence, transform. Each of those are going to have a state of stress associated with it. And we're just going to list those off right now. There is a compression state of stress, and compression is going to be associated with things coming together. Arrows here, we are going to point crashing into one another. Compression is going to lead to shortening of like a rock or a plate tectonic boundary. It's going to be associated with plate tectonic convergence. And in where would you see this geographically? Mountain ranges like the Himalaya are being produced by compressive stresses due to convergence. Another state of stress we have is occurring at divergence, and this is called tension. For tension, I would like you to be picturing arrows that are pointing away from one another. This is going to be associated with stretching or extension. stretching / extension, as things are being pulled apart. Tectonically, this is divergent plate boundaries. And our geographic examples could be the mid-ocean ridge or East Africa. Okay, and now the third state of stress is shear. Shear is a differential, pulling and pushing in two different directions. And so our arrows, we could have one arrow pointing this way and one arrow pointing that way. And the word we're going to associate with shear, well, let's just say opposite directions. Do you remember the plate tectonic boundary that's associated with this? Transform. So like the San Andreas fault would be a good example of a system that's experiencing shear, and shear is very, very common. Shear is a horizontal motion primarily, whereas compression and tension are going to lead to vertical changes across faults, just as a heads up about where we're going. Now next up, let's define fault. This will take a second as I write it out. Let me read it to you first and then I'll write it down. It's a fracture in the lithosphere where motion along the break has offset opposite sides. All right, so fracture just means break. So it's a fracture in the lithosphere. The asthenosphere is viscous and moves, and so we don't think faults exist down there because they would just seal up. So it's a fracture in the lithosphere where motion on or along the break, the crack, has offset opposite sides. Some phrases we could put here. So a fault, even shorter definition, offset rocks. We could also say, it is a good word, maybe harder if you're learning English, juxtaposed rocks. Juxtaposed means two things set next to each other that shouldn't be. Another word associated with faults is this word displacement. Now to finish off this lecture, what I'd like to do is show you a couple pictures of faults and then define some parameters. So let's go ahead and just throw one of these in. Here's a fault from, I believe, Japan. And in this olden day picture, right after the fault occurred, we can see that this is the fault surface, the break at the Earth's surface. We see offset of this road, right? Not only has it gone up, it's also gone a little bit to the left. And what's kind of cool is we can see the same trace of that fault today. Maybe what is it? Maybe 80 years later, and maybe the people have started to forget that this little hill is not just a hill. That's movement along a fault as they drive along that road. Okay, so what we're going to do is we're going to start with the drawing, and then we're going to define parts of a fault. So here is our land surface, and then here is a fault going down into the subsurface, and here is the other part of the land. And so we have this block that has created a displacement. This distance right here is our displacement, our offset. And the actual break on the Earth's surface, this is called a scarp. Good. The place where the actual energy is released is down here in the subsurface, like where the main break is, and we call that the focus. The area directly above the fault at the Earth's surface, we'll put a star there, that's called the epicenter. That's a word you often hear in the news. And then we're going to put a couple more words in. Let's call this the foot block. And this is a different block. In this picture, this is the hanging block. All right, so those are our main terms defining faults, and we're just going to write those down, and then this lecture is over. So focus equals location of main break the epicenter is the surface location above break. The scarp is like a topographic feature. Let's say surface expression of rupture. And displacement, this is the amount the two sides are moved. What's the best way to say this? Let's just call this the amount of movement. And when we talk about scarp and displacement, we could be talking about it as a one-time event from one earthquake, or we could talk about it as a long-term, what has happened over the last 1,000 years. Here's an interesting word I'll introduce. Gouge. That's like all the broken and shattered rock. I'm kind of stippling it in here along the fault. We're going to call this broken rock. On fault surface. All right, that's some good vocabulary. I'll see you next time for a little bit more.